In the last video, we were talking about the exterior angle theorem. In this video, these two guys have some special properties. One is isosceles, and the green one is an equilateral. Here in the isosceles, you have two congruent sides, and the third side is going to be a different length. The thing about isosceles, other than the fact that two sides are congruent, is that you have these two base angles down here, and those angles will also be congruent because the sides are congruent. Doesn't that make sense? See what happens when I make things a little bit different? You can see these two congruent sides are still there, but the base angles are also equal, even though I changed the sides. So anytime the sides are equal, the base angles across from them are going to be the same size as well. All right, let's take a look at the equilateral triangle. I can make this different size. Angles on the inside all have to be 60. And the reason is, you could probably figure that out, but all the angles inside of a triangle have to add up to 180. If all the sides are going to be the same length, we talked about this thing is equal angular, so they're all going to be 62. All right, for your notebook, we are talking about isosceles and equilateral triangles today. So isosceles triangles, they have two equal sides, and the third side would be a different length. And the base angles are always going to be equal. Equilateral, it has three equal sides, and all the angles are always going to be 60 degrees. Pause if you're copying. I'm moving on. Let's do a problem. Let's do two problems. All right, find the value of x. This one's easy. I mean, we're just warming up here. So for this first triangle, you got to figure out, well, they're telling me that these two angles are equal to each other. If base angles are equal to each other, this is an isosceles triangle. So the sides are congruent. That means x equals 11. On this triangle, all three angles are equal to each other, so this is an equilateral triangle. It means all the sides are going to be the same length, so x also equals 6. That is just to check to make sure you're on the same page as me. That is not the kind of problem you're going to see in a high school geometry class. Find the value of x. All right, we've got an isosceles triangle on this one. This base angle here is 37. We know that the two angles are congruent, so that means this guy is 37 too. X is not 37. This is isosceles. This is the top angle that is different than the other two. So let's add those two together, and we end up with 74. And then let's take the 74 away from 180, and we end up with 106. And that's our answer. Now, I did this without making an algebra equation out of it, just for those of you who don't love algebra as much as I love algebra. Now, the other one, I mean, this is like insulting. The answer is 60. Aren't those fun, though? I mean, you're going to get those right if you remember that and you don't overwork it. Like I said, too easy. It's boring. Now it's getting a little more interesting. I've got two problems on one page here because I'm comparing and contrasting isosceles and equilateral, because sometimes people get them mixed up. The isosceles has two angles that are marked congruent. These are base angles. That means the two sides are equal to each other. So when I set this up, it's algebra. I'm going to go 2x minus 13 equals the 9. Geometry done. Now we do the algebra. Add 13 to both sides, and we get 2x equals 22. Divide by 2, x equals 11. Let's look at the equilateral. Well, if all the angles are marked as congruent, that means all the sides are the same length, so we're going to set it up and do it the same way. 22 plus x equals 12. Subtract 22, we get x equals negative 10. And now you might be thinking you can't get a negative number in geometry. Well, yeah, you can. Substitute the negative 10 back in here. That's what makes this 12 long. It has to be 12 because this side is 12. Find the value of x. What kind of triangle? This is an isosceles. And look, they made the line down here longer to give you a nice little exterior angle to look at, but you're not looking for that angle. You're looking for x, and it's telling me that the measure of angle 2 right here, this isn't 2 degrees, it's just angle 2, is 11x minus 2. So what to do with that? But I know these two base angles are equal to each other, so I know that if this one is 11x minus 2, This one must also be 11x minus 2. First thing I'm going to do, though, is I have this 30 degrees. This is not one of the base angles, even though it's on here on the bottom. This triangle's been tipped over. These are the two congruent sides. This is the top of that triangle. Let's subtract that 30 from 180, and we know that we have 150 degrees between these two. These two have to add up to 150 degrees. Well, if you take 150, there's more than one way to do this problem, by the way. This is just the way my brain is working right now. If you take this 150 and divide it into two equal parts, that means each one of them would be 75. 75 plus 75 is 150. Now I am going to take that 11x minus 2 and set it equal to 75. Finding that 75 makes this a little bit easier. I'm going to add 2 to both sides. I get x equals 11x equals 77. So x must equal 7. All right, find the value of x again. And then now the angle 2 is here. They're giving me an algebra expression for it, x plus 72, but they changed the triangle. So we already know what angle 2 is supposed to be, right? That's going to appear. That has to be 60 degrees. They're all 60 degrees in an equilateral. So let's write it up. X plus 72 equals 60. Subtract 72 from both sides, x equals negative 12. I told you, equilaterals are a little easy. Okay, what's going on here? I got two triangles that are like snuggling up to each other here, and they're sharing this side right here. It looks like they're both isosceles, and more so than that, it looks like all these angles are the same. If they were different, one of these pairs would have had 2 arc measures, and they just all have 1, so all these angles are the same. That's interesting. All right, let's figure out what we got. If this is isosceles and these are the base angles, then this side and this side are the ones that are equal to each other. And this one are equal to each other. But they're all equal to each other in the whole diagram, you guys, because of these angles being the same. So whatever this side is, it's the same as this one. And these angles are the same as these, so these sides are also the same length. That means everything's 11. So let's set 2x minus 13 equal to 11. Add 13 to both sides. 2x equals 24. X equals 12. Tricky problem. We have to see some of these tricky ones because you're going to see them in class. All right, where's angle 2? It's over here. And it is 4x plus 10, and we need to find the value of x. And of course, they didn't tell us anything about the triangle where angle 2 is at, other than that it's isosceles. These two sides are the same, which means the base angles would be equal. The only number we have in the problem, 80 here, so these two sides are equal to each other, but they're not equal to these. See how this one has 2 markings, and these just guys have 1. All right, let's see what we can do. Well, we know that angle 2 is 4x plus 10, so this must be 4x plus 10 as well, which means this angle is also 4x plus 10. These are vertical angles. That was a video from a long time ago, but vertical angles, the kind that make these little bow ties, they're congruent, which means that one is going to be congruent to that as well. All right, let's get some angle measurements for these guys down here. Because we have the 80, we can subtract that from 180, and we get 100. So I'm going to pull that same trick I just did, and I'm going to split that 100 up over each one of those base angles because those are equal to each other. Okay, now we got it. 4x plus 10 equals 50. Subtract 10 from both sides in your head. We get 4x equals 40. Divide both sides by 4. And we get x equals 10. Hey, if you like how I teach, it would help me out a lot if you would like the video, subscribe, share it with your friends so I can find more people that I can help if they are in geometry or algebra 2. Click on the next lesson if you're ready for it. Click on the previous lesson or the playlist. I'll put that here, so if you want to go back in and get some old ones. Thank you guys so much for watching. I'll see you in the next one. Bye!